For the second day of the second unit, we are going to be factoring trinomials. When we factor trinomials, what we're looking for is first to make sure that we have a trinomial, and a trinomial is going to have three terms. So if you are given an original problem and told to factor it and it only has two terms, you automatically know that you're not going to be using this method. The trinomials that we're factoring today are going to be ones that have a leading coefficient of 1. And if you look over here, you can see that all of these have a leading coefficient of 1, each and every one of those examples. And the ones below on this paper are all the same way. So when we're doing these kinds of questions with a leading coefficient of 1, we're always looking for numbers that multiply to the end number and add to the middle term. When we're working on these kinds of questions, one of the things that they're pointing out to you here is that if you have a plus sign with your last term, you're going to know that both of the parentheses are going to have signs that are the same. If by chance you have a plus sign at the beginning, it's telling you that in your parentheses you're going to have both pluses. So they're the same and they're both positive. If you look at this one where we had the plus sign here, we have a minus sign in the front. The plus sign at the end tells us that our parentheses will be the same. The first one tells us that they're both going to be minus. And then if we have a minus sign at the end, which you can see in the second example and the fourth example, that means that our signs are going to be different. So we will have one plus and one minus. So if you look here at this factored form and this factored form, there's one plus and one minus. And the rule that goes with that is going to be that whatever sign you see in front of the middle term is going to be what goes with the bigger number. So you decide on the numbers that are going to be in your parentheses, and the larger of the two numbers gets the sign that's on the middle term, and then by default the smaller number will get the other sign. So we're going to go ahead and take a look at a couple of examples here. And when we look at these examples, we're going to keep those rules from up above in mind. On question number 1, I am looking for numbers that add to 9 and multiply to 14. And I'm going to list those numbers out. When I list those numbers that multiply to 14, I know I can use 1 and 14 or 2 and 7. I'm going to pick the ones that also add to the 9 that's right here. So when I go through and do this factoring, I know that I'm going to be using these numbers because they multiply to 14 and add to 9. When I do this, I make two sets of parentheses. X times x is what's going to give me that x squared. And I'm picking numbers of 2 and 7 because they add to 9. And when we go in and we look at the signs, because of this sign here, it tells us that they're going to be the same in the parentheses, either both plus or both minus, and this is telling me that they're the same, and because of that plus sign, both positive. So there's going to be my factored form. The numbers in the parentheses do multiply to the 14, and they do add to the 9 that we have there. When I go on and do question 2, I'm using the same process. I know that there's a 1 in front of the x squared, and there's 3 terms, which means I'm looking for numbers that add to negative 15 and multiply to 14. So when I look at numbers that multiply to 14, I have that same set of numbers. I have 1 and 14 and 2 and 7. And again, I'm going to pick the ones that either add or subtract to this number here. These are going to be the ones that I'm going to use this time, because in this case, the 1 and 14 will add up to give me the 15. I make my two sets of parentheses. To get x squared, I have to have x times x. To multiply to 14, I'm going to use 1 and 14. I go back now and I look at my signs, and what the signs tell me is that because that's a positive, they have to be the same. This tells me what they both are. So in this case, they're both negative. And that's going to be my factored form. When I go on to questions 3 and 4, I'm using the same process. In this case, though, one of the things that I do notice that is different is the fact that there's a minus sign on the last term, both of them, which means that my signs have to be different. So I'm going to have different signs in this case. So when I set up my parentheses, I want to keep in mind that in both of these two cases, the signs will be different. So I start this question the same way. I take a look at the number at the end. I want numbers that multiply to 18, add or subtract to 3x, and the x squared means that my two parentheses are both going to have an x in them. So I want numbers that multiply to 18. My list is 1 and 18, 2 and 9, 3 and 6. I want the numbers that are going to add or subtract to give me this 3. These are going to be the numbers that I pick. So I know I'm using a 3 and a 6. This negative sign tells me that the bigger number is going to have to be negative. So I go and I take a look. What's bigger, 3 or 6? Well, 6 is bigger, so that's the negative. And if I have to have different signs, this must be the positive. And I can always check this. So one of the things that I know is that my numbers in the parentheses, remember how we started this question, my numbers in the parentheses have to multiply to negative 18 from back over here. And they have to add to negative 3, which they do. So that's a quick little check for me to know that I factored that correctly. In question 4, we want numbers that multiply to 35. So I'm going to do 5 times 7, 1 times 35. My numbers also have to add or subtract to 2. So that tells me that my numbers are going to be 5 and 7. Notice in this case there is a little bit of a change here. Instead of having x squared, we have m squared, so it's m times m. Remember, this tells me my signs are different. And if I take a look at this sign that's in here, it's a plus sign. That means that my bigger number has to be positive. What's bigger, 5 or 7? 5 is bigger, it's the plus. 7 is bigger, it's the plus. 5 then by default has to be the opposite sign, which is going to be a minus. And again, if you wanted to check these, remember the numbers should add to 2, multiply to 35. So when I multiply them, I get negative 35, which is what I wanted. When I add them, I get the positive 2. So a quick way to go through and check and see if what you're doing is right. Okay, so please turn the page. We're going to flip over, and on the next page, we're going to do a little review on factor by grouping. So when you do factor by grouping, the reason why it's called grouping is because you're going to group things in 2 groups of 2. And you'll see what I mean when we look at the example here. So when we do grouping, one of the key characteristics that makes you think that it could be grouping is that you're going to have 4 terms. That should make sense. 2 groups of 2 means you need to have 4 terms. And we're going to group them. So you can see in the directions here, we basically went in and grouped the first 2 together and then the second 2 together. And then our next step is we were going to factor using GCF. So when I look at these 2 terms, here's the GCF. And when I look at these 2 terms, here's the GCF. Now, when you factor that GCF out, you may not realize it without pointing it out to you, but when you do that, notice how these 2 are the same. Because those 2 are the same, what that means is I can look at them and say, oh, the first term and the second term both have a common factor of x plus 2, so let's factor it out. And when I factor it out of here, I'm left with 3x. And when I factor it out of here, I'm left with plus 4. So basically, I'm doing a GCF factoring 3 times, twice in this line, and then once more I'm doing a GCF in this line, so basically 3 times. They give us another example when we're factoring out a negative number, so you can see that when they did this next example, factoring out a negative number, I see that there's 4 terms here. That means that this is factor by grouping. In this particular question, they've grouped together the first 2 and the second 2. They've taken out of this a GCF And notice here's the leftovers. And then when I look at the second one here, they took out a GCF of -4. And here's the leftovers. So remember, our next step is going to be to say, oh, look, there's a common factor here and here. If I had not taken out the -4 and I had taken out a +4, in this location right here, my parentheses would not have matched. And that's one of the things that has to happen is when you go through and do this, you have to have a common term that you can say, oh, look, this term and this term both share an x minus 2. If I take it out and put it here, I'm left with a 3x. If I go back and I take it out here, I'm left with a -4. And that automatically becomes in its factored form. So it takes a little bit to get used to this process. We're going to do a couple together just so you can sort of get the hang of it. When we're doing these, remember it's factor by grouping. If you look at questions 5, 6, 7, and 8, they all have 4 terms. That means we're going to go in and group things together. So the first thing I'm going to do is I'm going to group these two together. And then when I go through and do this, I'm going to group these two together. I'll do it in a different color. I'm going to group these two together. So when I do my factor by grouping, I'm looking here and I'm saying, what do those two both share? And I can see that they share an a. And if I divide the a out, I'm left with x plus 7. When I look at the next two terms, I can see that I can take a -3 out. I'm always conscious, is it going to be positive or is it going to be negative? But if I take a -3 out, what that really means is that when I go in here, I'm really dividing these two terms by -3. And when I do that, I end up getting a positive x and a positive 7. That's exactly what I want, remember, because these two both have to share a common term. So when I look at this, I can say, oh, look, both share a common term of x plus 7. If I take it out of here, there's an a that's left. If I take it out of here, there's a -3 that's left. And this is considered my factored form of the problem that was originally given. When I move on and I start looking at question 6, I'm going to group these two together and group these two together. When I group the first two together, they both share an x. When I divide both of them by that x, I'm left with a plus b. That means that when I factor the other one, I'm going to want to have an a plus b in there as well. I just had to fix that there. That wasn't looking so good. Okay, let's go back. So I have to say to myself, do I want to take out from this a +4 or a -4? And we can always try one. And if it doesn't give us what we need, well, then we can go back and change that. So I'm going to take out a +4. And when I do my dividing, I'm left with a plus b. So it's a confirmation that what I did here was right, because now when you look at this, they both share an a plus b. And then when I go back and say, okay, well, what's left over? What's left over is this x plus 4 that's here. So I'd like you right now to please pause this video and try questions 7 and 8 on your own. And when the video resumes, you will be able to check your answers. Okay, so technically right now you should have questions 7 and 8 done. If you don't, please pause the video. And we are going to do factor by grouping. So I'm going to group together these two, and I'm going to factor out a 3x, which leaves me 3x plus 2. When I group together the second two, I'm going to factor out a +4, which leaves me 3x plus 2. And then when I look at this now, I can see that both the first and second terms share a 3x plus 2. So I'm going to factor them out. And when I factor them out, I'm left with 3x plus 4. So I did a GCF on this, a GCF on this, and then I viewed this and this as two separate terms that both had a GCF that could be taken out of them as well. When I go on to question 8, I'm going to group these two together and these two together. When I look at what I can take out of the first term, I can take out an x, which leaves me 2x minus 3. When I go on to question 8, I'm going to take out a negative 2, because if I divide both of these by negative 2, I end up with that 2x minus 3 that has to match the other term. So now I can see that both of these share a common factor of 2x minus 3. So I'm going to factor it out. 2x minus 3, what's left? An x minus 2.